When we left off, we had found the equation for y0. I didn't find the equation for y1 or y2 or for the output, but you do those the same way. Only difference is the output does not depend on the input, so that one would only use a 3-variable Carnot map. So you do those equations the same way. You just set up the Carnot map and see what you can find. Now, your next step in lab is going to be to write the Verilog. And I have found that this basic template that I'm going to show you for whenever you've got a sequential circuit will be very handy to kind of do it this same way. So I'll just call this one Lab 6 Lab 6 Fall 2024. Okay, and we have a clock as an input. We had what did I call that? T was our input variable, and V is our output variable. We also have output as present state. That tells us what state we have. And present state is 3 flip-flops, so it's 3 bits. So I have it as going from 0 to 2. I have it as a reg because I'm going to set it in my always block. Because the way I'm usually going to set these things up is I'm going to have one always block for determining what the next state is, and then another always block that only occurs on the clock edge that just changes the state. Now we need parameters for all of our... You don't have to use these, you can use the binary numbers, but it's a lot easier to set them up as parameters. Let's see, we had 0, 0, 0, 0, 0, 1, 0, 1, 0, and this would be 0, 1, 1, this would be 1, 0, 0, and this would be 1, 0, 1. Alright, and then always at, so we're going to have this block operate anytime either our input changes or our present state changes. We can calculate the new present state. So it'll be based on our current present state, and then within our current present state we're going to check and see what we have. So with case A, okay, this will be a little bit different than what I showed in class, because what I showed in class would be more appropriate if the output depended on the input. It'll still work fine, you just have to type a little bit more. But here I have if I'm in state A, and let's take a look at what it looks like if I'm in state A. So if I'm in state A, my output is 0, and if T is 0 I go to B, and if T is 1 I stay in A. So I can say first of all that V equals 0, and then I'd say if T equals 0, then next state, so here in my always block I am just figuring out what my next state is going to be, but I'm not actually changing it yet. So my next state is going to be, if it was 0, my next state was B. else, my next state is equal to A. I'm using the non-blocking assignments. Probably it'd be fine to use equals here. Just don't want it, yeah, probably fine to be equals. I do have a begin and end on my A. I don't have a begin and end on my if or else because I just have one line for each one of those. Okay, now for B, for state B, I had still true that my output equals 0, and if T equals 0, B is D, otherwise it's C. And then for state C, I had E and A, and my output was 0. And then for D, we had F and C. And then for state E, we had our output was finally 1, and D and C. And then state F, we have V is 1, and F and C. Okay, and then we need to have a default since we have those don't cares in there. And so our default case is that the next state, I would have the next state be A to go to our reset. And our next V would equal 0. Looks like I forgot. I was calling those V's and not next V. I think I want them to be next V. Because I don't want anything to happen until the clock changes. Make it end the case, and then we end the always loop. Did I begin the always loop? I did not begin the always loop because I only had one thing in it, which is the case statement. And then we have our second always loop, which is always at the positive edge of the clock. And we're going to change our states, and we are going to produce the output. And then you will save it. And then you will run a synthesis. No, I lied, that's not it. You will run an implementation. Well, of course, my synthesis just failed because I forgot to set my constraints. So let's do that. So if you go to the website for the class, and you look in the SI resources, you will see file for constraints. So you will want to take that and copy it. Okay, I am going to have to stop this one here. Just I'm out of time. I'll pick it up and add to it in a little bit.